You're welcome to this year's Mechanics WAEC 2025 Physics Practical Solution, question 1. Well, a lot of my students have asked me to make an analysis of this, and I've decided to put this on show. These are 3 rated stands, 1, 2, 3, all right? And then there are 2 meter rules, 1 meter rule, 2nd meter rule. Now, this is how you arrange the meter rule. This one from 0 to 100. The second one from 0 to 100, like this. So you are provided with 3 rated stands with clamps, a spiral spring, 200 centimeter rulers, 100 gram mass, labeled M, 3 pieces of thread with loops, stopwatch, optical pin, sellotape, and other necessary apparatus. Well, I'm not saying that this is the actual WAEC question. I just simulate this to show you what you are expected to do. But WAEC may come with a different thing altogether. Now, 1, set up the apparatus as shown in the diagram above without the 100 gram mass, okay? Without this 100 gram mass, you set up the apparatus without this 100 gram mass, all right? Tie one end of the string to the meter rule at the 5 centimeter mark. Now look up, this part of the string to the 5 centimeter mark, all right? They will give you the height of the meter rule, okay? Here I just assume this to be about 30, to the 30 here, 30 here. Mark you, there is a spring, the spiral spring is fixed here to the rotor, and then part of it is joined by a small string to the point B, all right? Now I said, tie one end of the string to the meter rule at the 5 centimeter mark, point A, all right? And one end of the second string to the rule at the 95 centimeter mark. The other end to the 95 centimeter mark. Invariably, the distance between A and B will be what? 90. Are we there? All right? Ensure the meter rule is at the same height, H. At the same height, H. Are we there? Attach the optical pin. This is the optical pin, which is an indicator, to the lower end of the spiral spring. A short string connects the spring to loop B. A short string connects the spring to loop B. Now let's go to 4. Read and record the position of the optical pin L0. Now by the time you attach this, the optical pin will give an indication, all right? You read it from down, 0 to whatever it indicates. That would be your L0. Are we there?
Yes.
Now 5, suspend the 100 gram mass by means of a short loop at x is equal to 20 centimeters. I just chose this, all right? 20 centimeters. That means you have to remove this loop and then put this 100 gram mass by means of a short loop, then move it to the 20 centimeter mark. You move it to the 20 centimeter mark. Definitely, this spring will depress down, okay? That will be your L, all right? That will be your L. Mark, we've already gotten our L0. And then by the time we load this with the 100 gram mass, we get our L, okay? To go down again, we get our L. Now we said, evaluate E, that's the extension, is equal to L0 without loading minus L, all right? Now, 7, set the meter rule into vertical oscillations. Once this is done, what you need to do is just to press this a little bit down, okay? It will go into vertical oscillations, right? Set the meter rule into vertical oscillations. Determine the time T for 20 complete oscillations. Now it goes up, come down 1 to 20 oscillations, right? Calculate the period T, all right, of oscillation and evaluate T squared. You know how to calculate the period T, all right? That's T divided by 20 oscillations. That will give you capital T, which is the period. Repeat the procedure. For x is equal to 30 centimeter. That means from here, 20, you move it to 30 centimeter, 40 centimeter, 50 centimeter, and 60 centimeter, respectively. In each case, determine the values of L, E, T, capital T, and T squared. Ignore the mass of the meter rule. You have to ignore the mass of the meter rule, right? They may ask you to ignore, or they may ask you to measure the mass of the meter rule and indicate it, right? And tabulate your readings. Plot a graph of T squared on the vertical axis against E on the horizontal axis, starting both axes from the origin, 0, 0. Determine the slope of the graph. 10. State 2 precautions taken to ensure accurate results. Now, BI. What forces kept the spring vibrating up and down? State the energy changes that took place during the oscillation. II. From the slope of the graph, calculate the acceleration due to gravity. So we went further to give you, to simulate a table, all right? Now this is the distance in centimeters from O, right, from A, all right? 20, 30, 40, 50, 60. This is our extension, which is our original L naught, which is constant, minus the new length when you add this mass and then move it, okay? Then when we set the meter rule in oscillations, the time for 20 oscillation, we record it here. Now if we divide this time by 20, it will give you the period. Then we square this. Are we there? I think let us proceed to take the practicals.